Welcome back. Welcome back to the channel. Today we're going to be focusing on severity number 8 in the OWASP top 10, insecure deserialization. This is also task 21. OWASP 10.8, insecure deserialization. Insecure deserialization is a vulnerability which occurs when untrusted data is used to abuse the logic of an application. This definition is still quite broad, to say the least. Simply, insecure deserialization is replacing data processed by an application with malicious code, allowing anything from DOS, denial of service, to RCEs, remote code executions, that the attacker can use to gain a foothold in a pen testing scenario. Specifically, this malicious code leverages the legitimate serialization and deserialization process used by web applications. We'll begin explaining this process and why it's so commonplace in modern web applications. Now, it's ranked as 8 out of 10 because of the following reasons. Low exploitability. This vulnerability is often case-by-case basis. There's no reliable tool or framework for it. You'd have to actually search by yourself. Because of its nature, attackers need to have a good understanding of the inner workings of the TOE. The exploit is only as dangerous as the attacker's skill permits. Kind of like everything, unless you're a script kiddie or you're able to purchase stuff online, but that's besides the point. So, for example, someone who can only cause a DOS will make the application unavailable. Now, that can be useful in certain scenarios, but you're not really, that's really low level kind of skill right there. Business impact of this will vary on the infrastructure. Some organizations will cover just fine. Others, however, will not. At summary, ultimately, any application that stores or fetches data where there are no validations or integrity checks in place for the data queried or retained. A few examples of applications of this nature are e-commerce sites, forums, APIs, application runtimes such as Tomcat, Jenkins, JBoss, and etc. This is just going to be a quick little intro to insecure deserialization. So who developed the Tomcat application? Let's go ahead and check Google. James Duncan Davidson. The full name. Apparently, it's a trick question. So, yeah, no. Let's just go with the Apache Software Foundation. I think what they're trying to do is get you used to thinking about things in a certain way. The answer is correct. The Apache Software Foundation. What type of attack that crashes service can be performed with insecure deserialization? Also known as DOS. Yeah, we're going to type DDoS. Denial of service. Maybe that is their denial of service. Yeah, as you can tell from the small hint. So that would be denial of service. Cool. Moving on to task 22, insecure deserialization of objects. Looks like there's going to be quite a few here. Prominent objects. Prominent element of object-oriented programming. Objects are made up of two things, states and behaviors. Simply, objects allow you to create similar lines of code without having to do the legwork of writing the same code lines again. For example, a lamp would be a good object. Lamps can have different types of bulbs. This would be their state. as well as there being an on and off, which is their behavior. Rather than having to try to accommodate every type of bulb and whether or not that specific lamp is on or off, you can use methods to simply alter the state and behavior of the lamp. Select the correct term of the following statement. If a dog was sleeping, would this be a state or a behavior? Take a wild guess here. Say the state would probably just be the dog. And the behavior it would be doing is sleeping. So, did I spell that incorrectly? Answer A is going to be okay. Well, apparently they didn't like us typing in a behavior. So if you just type in behavior lowercase, it will then parse for you a behavior and you'll get the correct answer. Moving on to task 23. Insecure deserialization, deserialization. Learning is best done through analogies. A tourist approaches you in the street asking for directions. They're looking for a local landmark and got lost. Unfortunately, English isn't their strong point, and nor do you speak their dialect either. What do? You draw a map of the route to the landmark because pictures cross language barriers. They were able to find the landmark. Nice. You've just serialized some information where the tourist then deserialized it to find the landmark. Serialization is the process of converting objects used in programming into simpler, compatible formatting for transmitting between systems or networks for further processing or storage. Alternatively, deserialization is the reverse of this, converting serialized information into their complex form, an object that the application will understand. Say you have a password of password123 from a program. So what does this mean? Say you have a password or a password123 from a program that needs to be stored in a database on another system. To travel across the network, the string and or output needs to be converted to binary. Of course, the password needs to be stored as password123 in plain text and it's not binary notation. Once this reaches the DB, it's converted or deserialized back into the password so it can be stored. How can we leverage this? Simply, insecure deserialization occurs when data from an untrusted party gets executed because there's no filtering or input validation. The system assumes that the data is trustworthy and will execute with no holds barred. Now, this is a great way to get this concept is a great way to do like privilege escalation in a lot of systems, but that's way beyond the scope of today's lab. What is the name of the base 2 formatting that the data is sent across a network as? Now, if you're not familiar, you could Google it. However, the answer is always, or similarly, it tends to be in the text a lot of these times. So the answer is binary. Let's move on to task 24, insecure deserialization of cookies. Yes, the origin of cookies 101. Now, if you're watching these videos and you haven't noticed my cookie on my page, go take a look and hit that subscribe button. Thank you. But moving on. Yes, the origin of many memes. Cookies are an essential tool for modern websites to function. Tiny pieces of data. These are created by a website and stored on the user's computer. Example is that is we use cookies to ensure you get the best user experience. For more information, contact us. You'll see notifications like the above on websites these days. Websites use these cookies to store user-specific behaviors like items in their shopping carts or session IDs. That would basically keep you logged in. Had you logged into whatever application that you're logging into. In the web application we're going to exploit, you'll notice cookies store login information like this. We've got password, IP. We have all the same IP here, but it's going to store cookies for the session, for the pass, the timestamp of when that user logged in, session ID, username, user type. While plain text credentials is a vulnerability in itself, it's not insecure deserialization, as we have not sent any serialized data to be executed. Cookies are not permanent storage solutions like databases. Some cookies, such as session IDs, will clear when the browser is closed. Others, however, last considerably longer. This is determined by the expiry timer that is set when the cookie is created. Some cookies have additional attributes. A small list of these are listed below. Got attributes, description, and required. So we got the cookie name to be set. Yes, it's required. The value of the cookie can be anything, plain text or encoded. Secure only will be set over HTTPS connections, is not required. Expiry is also not required. If you ever notice you go to some website after a long time and you're still logged in upon typing that in, that would be an example, as well as the path. Creating cookies. Cookies can be set in various website programming languages, for example, JavaScript, PHP, or Python, to name a few. The following web application is developed using Python's Flask, so it's fitting to use in this example. So example is date time is equal to date time dot now, and that will set the time of now, right? So it's going to give you an indication of what time the user is used or logged in. Timestamp is equal to string of date time. Response.set cookie is registration timestamp. Setting cookies in Flask is rather trivial. Simply, the snippet gets the current date and time, stores it within the variable timestamp, and then stores the date and time in a cookie named registration timestamp. This is what will look like in the browser. We have registration timestamp, IP, session, and we have the date here, as well as the time. It's as simple as that. Answer the questions below. Question 1. If a cookie had the path of webapp.com/login, what would the URL that the user had to visit be? That would be the login page. webapp.com/login. What is the acronym for the web technology that secure cookies works over? I believe it's HTTPS. There we go. All right, moving on to task 25, insecure deserialization cookies practical. All right, let's take a look at task 25. We had to reset the machine. And secure deserialization, cookies practical. Accessing your instance. In this browser of the device that you're connected to, the VPN with, navigate to 10.10.9.141. I'll be detailing the steps to Firefox. You may have to research how to inspect cookies in the browser of your choice. This will be you will be greeted with the home page of Exchange Your Vim here. So 10.10.9.141. 10.10.9.141. Exchange your Vim. Join us. We've got a bunch of information here. However, we're just going to look at the cookies. You're going to want to go right click, click on inspect. And then here we have a bunch of information. Now, click on storage. It's going to be storing a cache, the DB information, the cookie information, etc. So that is how you do that. Let's actually read what's going on. Just create an account. No need to enter your details. You can enter what you like. We'll go ahead and create an account. Join us, probably be the easiest way. New user. Okay. Welcome new user. Participate in the latest quiz. Exchange your VM. Provide feedback. It's going to also show exchange history or update our profile if we choose to. Now you cannot click on those. So our profile, it's going to say our username, our access level, time of registration. So that would be the timestamp. Exchange, yes. Right click on the page, inspect element, navigate to the storage tab. It wants us to look at the cookies. You'll see here that these are cookies are both plain text encoded and base64 encoded. First flag will be found in one of these cookies. Modifying cookie values. Ooh, this is fun. Notice here that you have a cookie named user type. You're currently a user. I know where this is going. This would be lovely in the wild. You're currently a user as confirmed by information with the My Profile page. Yeah, this application determines what you can and cannot see by your user type. What if you wanted to become an admin? Double left click on the value column of user type to modify the contents. Let's change our user type to admin and navigate to the directory of the admin or the 10.10.9.141/admin and answer the second flag. So first flag is going to be the cookie value. We'll inspect the page. We will go to storage, and under cookies here we have the password that we set. We have registration timestamp. We have session ID. We've got our username and our user type. Now, what is the question again? It's asking a first flag of the cookie value. This would be the value that it wants. However, it's pretty long. So double click, copy it. The first flag is going to be the cookie value. I do not think it's going to like this because it's looking for THM cookie. So So because our value, session ID is encoded, we're going to have to decode this. Good time to go to Google and decode base 64. We'll go ahead and paste the value of the cookie in here and decode. If it's not base 64, it will be, what's the answer? Plain text encoded and base 64 encoded. So maybe if we get rid of that here. Even though that is part of the cookie. I fucking hate this website. UTF-8, however. Hey, yo, it's not decoding. Here, we'll go to base 64, decode. So, if you're going to go to a different decoder for base 64, you would have to know what the character encoding was detected as. Luckily, when we went to base 64 Guru, it's already going to do that for us, and it's ISO 8859-1, and it says it's inaccurate. However, this one is actually going to provide us with the answer. So as you can see, it's been able to decode the session here into 64, and we have the X session indicator and followed by some more information, but we have the cookie here, THM, good old base 64, huh? That is the answer. The machine is expired. However, we'll go ahead and enter that in. That is the answer. Let's see if we can try to get this to work. Doesn't look like the sessions actually disappeared on us. So, next question. Second flag, admin dashboard, right? So what we're going to want to do is change our user type here from user to admin. We now have admin privileges, and instead of my profile, we're going to want to just go to the admin directory. Now, if they were all this easy in the wild, it'd be very easy to, it would be very easy to get bug bounties, right? But this is unlikely. However, it is a possibility. And with that being said, we have logged in the admin dashboard. Hi, new user, support tickets. We could view those. We could view management of users. We basically have total privilege, right? However, here's the admin flag, THM. Here's the admin flag. So let's copy that. Go ahead and paste that in. That is the second flag. Moving on to task 26. Insecure deserialization code execution. All right, let's take a look at task 26. Insecure deserialization code execution. A much more nefarious attack than simply decoding cookies. We get into the nitty-gritty. Setup. First, change the value of the user type cookie from admin back to user. Go back to my profile. So we'll go back to inspect, back to storage, into our cookies tab. We'll change the admin back to user. And we will go back to my profile. Okay. Once you've done this, left click on the URL, provide your feedback, where you'll be directed to the login page like so. What the fuck? Okay. Internal server error. Interesting. Oh, let's try that again. Okay. Maybe we can just go to home. Okay. Feedback. Internal server error. Maybe we're not still the user here. Maybe let's double check here. We are. Interesting. Now, for whatever reason, this is not appreciating what we're doing here. So we're just going to create a new user here. And we've been disconnected from the box. Okay, well, we're going to restart the box. All right, welcome back. I'm going to finish up task 26 here. Insecure deserialization of code execution. So we're going to go navigate to the IP 1010.128.829. Load, baby, load. All right, we'll click on feedback here. Internal server error. This thing does not like us right now. This is not good. Let's try to inspect elements. Memory. If this doesn't work, bruh, we have to restart the whole fucking thing. Change this to admin. Go to admin. Cool. Blah, blah, blah. Oh, statistics. Nice. Okay. Well, then we need to go back to cookie. Change this back to user. We'll go to my profile. Provide feedback. Bruh. Bruh. Why the fuck did it work? Left click, exchange your VM file. First, change the user type from cookie from admin to user. Then left click on URL and exchange your Vim. Okay. Once you've done this, left click on URL, provide your feedback. Okay. Here we go. Now, what makes this form vulnerable? If a user was to enter their feedback, the data will get encoded and sent to the Flask application, presumably for storage within a database, for example. However, the application assumes that any data encoded is trustworthy, but we're hackers. You can only trust us as far as you can fling us, and that's nigh on impossible online. Although explaining programming is a bit out of scope for this program or for this room, it's important to understand what's going on in the snippet below. Cookie is equal to replace me and payload. Pickle underscore payload is equal to pickle.dumps of cookie. Encoded payload cookie is equal to base64.base64. It's encoding the pickle payload. And RSCP is make a response. So response is equal to make response and redirect to my profile. Response.set cookie, encoded payload cookie. When you visit the exchange, your Vim URL, a cookie is encoded and stored within your browser. Perfect for us to modify. Once you visit the feedback form, the value of this cookie is decoded and then deserialized. Uh-oh. In the snippet below, we can see how the cookie is retrieved and then deserialized via pickle.loads. So cookie is equal to request.cookies. It's getting the encoded payload. So whatever payload we can actually change here is going to encode and then decode. So that's probably what we're going to be doing as we move down, but let's just continue to read. Cookies equal to pickle.loads, base64 encode. Yeah, so that's exactly what it's going to do. But this vulnerability exploits Python pickle, which I've attached as reading material at the end of the room. We essentially have the free reign to execute whatever we like, such as a reverse shell. The exploit. Now, I'm not going to leave you hanging dry here. First, we need to set up a netcat listener on our Kali machine. If you're a subscriber, you can control your own in-browser TryHackMe Kali machine here. So NC netcat LVNP, and we're setting the port. Because the code being deserialized is from a base64 format, we cannot just simply spawn a reverse shell. We must encode our own commands in base64 so that the malicious code will be executed. I'll be detailing the steps below with provided material to do so. Once this is complete, copy and paste the source code from this Python file pickleme.py to your Kali and modify the source code to replace your TryHackMe VPN IP with your VPN IP. This can be attained via the access page. Okay, so let's go ahead and click on this. Downloading the payload essentially, right? Let me see. Yeah, so we're going to be importing this little bin bash shell. Import OS, commands, print base64, pickle dump. Okay. So once this is copy and paste the source code from this Python file to your Kali, yeah, we've done that, and modify the source code to replace your VPN IP with your TryHackMe VPN IP. Well, that's our target. What is our IP? Oh, we're okay. So what we're gonna do here is find our machine IP. IP config. Oh, IF config. Spending too much time in Windows lately. Hey, yo. Okay, so here will be our IP. They're not going to allow us to do it that way. Apparently it's not giving us an IP for some reason. Now, what we can do, probably download this file, and hopefully it will give us, okay, something went wrong. Interesting. Oh god, this is actually fucking more annoying than it needs to be. This can be attained via the access page. Let's hope this is our IP here. We really have no way to tell, because I can't actually ping myself. I can't actually look at my own IP, right? So SBIN IP is available in the following places. SBIN. Maybe I can't. And it's encrypted. However, let's see. This is pretty unfortunate. Hopefully that's our IP. I don't know why you can't actually look at your own Vim IP in here. Like that's literally ridiculous. But anyway, create a Python file to paste into. I've used rce.py for example. So what we'll do is we'll take pickle.me.py here. You could just use this. Doesn't really matter. Copy and paste the source code from this file to your Kali and modify source code to replace your VPN with your VPN IP. Let me open the file again. Yeah, that is super, super sus, bro. Let's try the IP we have here with the OVPN. Now, if we... this is going to be a problem. It's not going to work, but we're going to do it anyway. So instead of just copying, or instead of just keeping this pickle.me.py, let's actually go ahead and create a new file just to show how to do that. This is our box. That we'll try that second. Okay, so what we're gonna want to do. Yeah, bro, that's super sus. Still encrypted. It wouldn't make much sense to create a OVPN and then connect to it. So I don't see how that's even going to work. That's unfortunate, but alright. However, what we're going to do here is nano. We're going to create a file. I believe what they wanted to do, rce.py. So we'll nano rce.py. This is going to create a fresh file for us. And then what we'll do is wherever the downloaded file is, which is here, copy this information. It's not going to allow you to paste straight up. So open the clipboard, paste the Python script into the clipboard, copy it, and then we'll be able to paste it into the file we've just created. Okay. So we're going to try to replace this VPN IP with our IP address, which from the OVPN file, which is literally not going to work. 54.193.240.194. Copy this. You'll paste that here. Well, okay. Try that again here. Nano rce.py. Copy the Python script, paste it in the clipboard, copy it again in the clipboard, paste it into the nano terminal that we've just created, and let's replace this. Again, we'll open up the little notepad we have here. We're going to want to copy this 54.193.240.190. Copy that, put it into our clipboard so we don't have any errors. Just type it in, to be honest. 54.193.240.194, port 444. Control O, enter to save that, Control X to exit out. If we ls, we see our rce.py here. Paste the code from the GitHub, replacing your VPN IP with your TryHackMe VPN IP from the access page. Right now, I don't understand. Like, this is not really a good way to do this. This is like assuming that we're not already on the VPN. Or that we're already not on, that we don't have a fucking IP address already. Unless it's trying to teach us how to use OpenVPN within a Vim, which is, I guess that would make sense. But anyway, for now, execute rce.py via Python 3 rce.py. Note the output of the command will look something similar to this. And that is going to be our cookie that's going to create. So what we'll do is Python 3 rce.py. Okay, we've got our cookie here. Copy and paste everything in between the two speech marks, the data. In my case, I will copy and paste the GASBCG, AAAAA, blah, blah, blah. Yours may look slightly different. Just ensure that you copy everything in between the two speech marks. So that would be here, GAS, all the way until equals. Copy that. Paste the code into encoded payload cookie in your browser. So what we're going to need to do is actually go back to 10, 10, 10, 10, 10, 128.829, 128.89. We'll navigate back to the web page here. Just make sure that you're in the VM. Log back in. Go back to feedback. And then inspect. Go to storage. And we're going to be replacing our session ID with the payload cookie that we managed to create, which would be here. Copy all of this. And let's go ahead and replace it. Control V. Enter, just for safekeeping. Ensure the netcat listener is running. So you can clear this, or nc-lvnp 4444. I'm probably going to need to refresh. Grab the payload again just in case. And we're going to have trouble with this because it's literally, we don't have the correct IP address for our machine, which is a problem. All right. So, in order to get our VPN, what we'll do is we will open our terminal. We're going to open another terminal here, file, new tab, ls. Apparently it doesn't like that. Just okay, so we have that. Let's cd into downloads, ls. Apparently we don't have any downloads on this machine for some reason. That's very strange. Okay, well, all right. In the essence of trying to make this easier, I don't know if this is going to work, but we're going to try it. Okay, well, let's download the configuration file for the VPN. And it would seem like it's wanting us to do this in our actual machine. So if that's the case, cd the downloads and what? Cali, and then download, clear ls, and we have the VPN right here. What we're going to do is open VPN candidate 0.0.ovpn. That would be your username. And it's going to run here, start a VPN. So if that actually connected, when we refresh, we have our IP address. Okay. So what they wanted us to do is use our personal VM if you're not using the attack box, okay? So now we have an IP address, internal virtual IP address, 10.2.31.179. Copy that, add this to a note. well, actually, since we already have the pickle.py there, create another new, paste that here. Now, I assume we're going to be doing this from our own machine. I see. Okay. Interesting. That's cool. Okay. So essentially what we're going to do is go back to the attack box, right? Then we're going to go to our own Kali machine, create the payload rce.py. I'm going to take the payload here, copy that. And to make this easier, you could just grab the IP of your VPN and just put it into the TryHackMe VPN here. So 10.2.31.179 port 444. Copy all of that, go over into our external VM here, paste it, Control O to save the output, Control X, have the payload rce.py right there. We're going to set up a netcat listener LVNT 4444 here. We are going to split the terminal vertically, and then we are going to run the payload here. So Python 3 rce.py. We'll grab the cookie ID, copy that, and then when we paste it in the other VM, we're going to get a shell here. So we'll go ahead and use the clipboard. Just double check that that is the correct information here. Get the payload there. Then no, that's wrong because there should be a G in there. Copy that. Copy that. Replace it in the clipboard. Why does it does not fucking with us right now. Copy. Then we're going to replace the cookie ID with session ID. Enter. It should have gave us a payload. Should have gave us a reverse shell, but it's not. And I believe the actual answer is going to be slightly reversed. So, we'll copy the payload. And we're going to create this payload in our... Okay, so we're using the outside VPN to find our IP. Then we're going to have to go into the Kali or into the TryHackMe VPN here, and basically create the payload here on our machine. Do we have it? CD into, it don't matter, we can create this CD into desktop. One nano. That's fucking annoying. We'll open up a new terminal. Nano rce.py. And since we've already done this previously, we're just going to implement the IP that we're given by the OpenVPN access of 10.2.31.179. Paste that to the clipboard, copy it. Now just replace it here. Ten dot 2.31.179, port 444. Control O, Control X, LS. We have rce.py there. Python 3 rce.py. Generate the payload. Copy that. And start our listener before we implement this into the page. So we'll go back to the page, inspect, storage, I accidentally double clicked. Copy that. Go to the page. Let's refresh the page. So it didn't really want to give us a shell in our own VM, so we're using the attack box here to actually provide you with an IP. I'm going to replace this here with our newfound IP address on the attack box 10.10.66.204 and 10.66.204 4444. Control O to save, write it out, exit with Control X, clear that, NC-LVNP 4444. Get that ready, clear this. Then we're going to RCE, Python 3, RCE, if I can spell, .py. I can't type either, apparently, but whatever. Get the payload here. Okay. Copy this. Navigate to the web page. But before we do that, let's actually just make sure that our listener is running and ready. Listening, ready to go. Open the web page. That's not it. Open the existing web page. Paste it into encoded payload here. Just to be safe. Paste it here. See how that works? Not cool. Really not cool. I don't really like that. Over here. Copy that. Delete that. Go over to our terminal. Copy. Go here. Paste it. Hit enter. Now we can go to our terminal. You can see we do not have a shell. Okay. Refresh the page. It's hanging for a bit, so this is perfect. It's actually working. Go over to terminal. We've got a shell, baby. Good to go. Okay. ls. We can see wsg.py, server.py, teams.sock, dockerfile.py. Maybe another hiding the file. Let's see what else is next here. ls, blah, blah, blah. If you perform steps early, you find a remote shell to your instance. No privilege escalation is involved. Look for the flag.txt. There is a way to do this nice and easy, and that would be just to find the flag.txt. So, best way to do that. Alright, so instead of searching through all of these, I believe we can just do find dash name flag.txt. We shouldn't have to do dev.null. Deny, 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 deny. It's under user.html, I would assume. So cd user.html and it's in Docker file. cd to Docker file. Yeah. Interesting. Alright, well, let's list all files. ls-la. have the same information here. Alright, well, the flag.txt is hiding from us, so what we're going to do is find -all. We will, in quotations, we actually need name. We don't need names for using name of the file, so we'll quotation flag.txt and quotes. Then it's something dev to null is greater than let me look up the code here. Alright, so instead of searching hopelessly, let's bring up our little, what are the scripts, what are the commands that we have saved here? Find all name like txt, and 2 is greater than dev null, and what that's going to do is search for the flag and ignore everything ignore all the permission denied, essentially. So I'll go ahead and find name flag.txt. 2 is greater than dev /null. Double check 2 is greater than /dev null. Enter. Home semantic flag.txt. So cd into home semantic semantic. Okay, so cat home semantic. No, we're not going to be able to see the end of the directories. We just do cat. Is greater than dev null. Okay, try that again. I have to exit the shell, find all flag.txt. 2 is greater than dev null. We have to find all dash name flag.txt. 2 is greater than dev null. Cat. Alrighty. So we will catch home semantic CMANTC flag.txt. Cat the file, and we have our flag here. Copy the flag, and we'll paste it there, and that is correct. Now, for the severity 9 and 10, I've already completed this using ChatGPT, and that is on the front page of my YouTube. Feel free to check that video out. We go through the walkthrough of looking up the CVE associated with the bookstore that's on there, and then subsequently we hack into it, and you'll be able to finish the lab here.
you like the video, please like, subscribe, and comment, and thank you for watching. This will conclude the OWASP Top 10 series, and we will be